Hi everyone and welcome to a new video. In this video we're going to talk about the CPU, which is the central processing unit of the computer. And first we're going to talk about what is a CPU, and then we are going to see how does a CPU works, and we're going to talk about the specification of the CPU, and at last we're going to talk about the motherboards and CPUs. So first, we're going to talk about what is a CPU. CPU is the most important part of your computer. It is one of the most important part of your computer, and also normally it is called the brain of your computer because most of the processes will happen inside of your CPU. So now let's see how does a CPU works. In the previous videos, we talked about the secondary memory, which is your hard drive, and we talked about the primary memory, which is pretty much your RAM and your cache. And then we talk about the CPU in general, but now we're going inside of the CPU to see what is happening inside of the CPU and what component a CPU has. And know that this is a very simplified components of the CPU. CPUs today are very complicated, but the basis of the CPU, this basic algorithm, it is very similar to them, and this is the basis of how they work as well. So the first part of your CPU is the ALU. Not first part, but one of the parts of the CPU is your ALU, and it is a stand for arithmetic and logic unit. So what happens inside of this unit? All of the information or data will come inside of the ALU, and they will be manipulated here. So the manipulation can be an arithmetic operation, for example, addition, division, or multiplication, or other things, or it can be a comparison, or so many other things, but comparison is one of the most common processes that happen inside of the computer, inside of the CPU. So all of those happens inside of your ALU by using gates. We have different logic gates such as XOR gates, AND gates, OR gates, and NOT gates. And when you combine these gates together, you can do different operations. For example, if you add XOR to an AND gate, then you will have a half adder, and as the result of that, if you have a number, for example, if you have two numbers, it can add it together, and it will give you after the addition is done, it will give you the answer plus a carry. So that's what arithmetic logic unit does. It does the arithmetic operations, and it does the logical operation, for example, comparing and things like that. And then you have another unit which is called control unit. In your control unit, so everything in that happens inside of your processor, inside of your CPU, will be monitored by control unit, and it will give the instructions to the ALU and make sure everything runs smoothly, and it makes sure that everything happens the way that it's supposed to happen. So for example, it will let the ALU know that it has to do the addition, or if there is a comparison that happens in the ALU, then there is no output. So ALU send the flag to the control unit to say what is the result, and then after that the control unit will decide what will happen after that based on the instructions that comes from the primary memory. Then you have another unit inside of our CPU, which is called register unit. So register unit is a very temporary memory that whatever comes from the primary memory, it goes to the register unit, and then from the register unit it will go to the ALU. For example, you have number 1 and number 2. These number 1 and number 2 will go inside of your register unit, and you will give it to the ALU, and then ALU will add them together, and it will give you the result of 3. And either you want it to be saved in another space, or if you want to do some other process on it, then the control unit will decide on that. And then now let's talk about the CPU specification. So when you want to buy a CPU, you have to consider some factors. One of them is your CPU brands. There are 2 main brands for the desktop computers. One of them is Intel, and the second one is AMD. So it's mostly believed that Intel have a better performance than AMD, and Intel is more expensive than AMD, so AMD is more budget friendly. And then we have the CPU clock speed, which is another specification that is important to consider when you want to buy a CPU. And the CPU clock cycle, okay, so every instruction that goes inside of your CPU to be processed will go one by one, and the speed of when is the one is over and then the next one have to come in and be processed is decided by your clock speed. So the faster your clock speed is, the faster the information will be processed. And each clock cycle have a rising edge and a falling edge. So sometimes it should be on the falling edge, sometimes it's on the rising edge, and sometimes it's both on the falling edge and rising edge. So each one of these can actually speed up. If it is both on falling edge and rising edge, it's going to speed up the process that happens inside of your computer. So that is one of the most important things you want to consider when you want to buy a computer. But you don't need to go with the highest end of the clock speed, because that's more for people who are doing doing things that requires very high performance. And for example, if you are playing a very high-end games, then you would probably want to consider the highest speed for your clock cycle, but if the highest speed for your clock speed. But for the normal everyday use of your computer, you don't really need to go with the highest end of the speed. So you just want to consider based on your needs from your computer. And then you have the CPU cache. We talked about the CPU cache in the previous video, but just one thing to consider is that we said there are 3 levels of the CPU cache: level 1, level 2, and level 3. Normally, level 1 and level 2 have the lowest capacity in storage, so that's not how they measure the CPU cache. Normally, they go with the L3, because L3 is the highest storage level for your CPU cache. So that's where your that's how you normally measure your CPU cache. And then we have 2 more concepts that we want to cover. One of them is CPU cores, and the other one is CPU threads. So CPU core, and the simplified way to explain these 2 is to consider a store. You go and shop in a store, and then after that you want to come and check out, and there is one booth with one cashier in it, and there is a line of 7 people before you. So you will go, and you're the 8th person there that's going to check out. So consider the time that you're going to wait until you'll get to the cashier and you can check out. And then if, for example, this store have 4 booths instead of 1 booth, and in each one of these booths they have 1 cashier. That means that you don't need to line up over 1 cashier anymore, because there are 3 more cashiers there that you can line up. So if there are 8 people standing there, each 2 person can go to one of the cashiers and they can check out way faster. Now you're the 8th person, so you're going to be the 2nd person of the last booth. But still, think about it. It's going to be way faster. You're going to be the 2nd one who checks out instead of being the 8th one who checks out. So the performance is better. So now consider there are 4 booths, and in each booth there are 2 cashiers standing and check out each person. So now you're going to check out at the same speed as the first person who got to the store. So as you can see, the performance level is going to go way higher, and those booths are going to be the cores of your computer, the cores that is inside of your CPU. And when you have 2 cashiers, so you have 2 lines that can check out, so those are going to be the threads that is inside of your CPU. But still, you want to consider this. If you want to have so many booths with so many register, if you have lots of customers checking out. But if you don't have lots of customers, it's just a waste of energy to have lots of CPU working with the clock. So that's why you always want to consider the usage of your computer to buy the CPU that has certain clock speed or certain cache or certain number of cores and threads. You don't always need to go with the highest end one. So then let's talk about the CPU on the motherboard. Sometimes people think that, okay, so I'm going to buy the best CPU and then I'm going to save more money on motherboard or other part of the computer. But that's not how it works, because certain CPUs come with a certain motherboard, so you can't just mix and match them together, because the socket on each motherboard would fit certain CPUs. So if you choose your CPU, you have to go and check the certain motherboards that you can buy for it, or if you have your motherboard already, you want to go and check which CPUs you will be able to use on that motherboard. So that's it, and I hope you enjoyed this video, and see you in next video. Bye.